So consider designing a single class. So typically, just focusing too much on a single class is probably not a very good idea, unless it's absolutely isolated concept. But concepts typically do not exist in isolation. Rather, concept is defined in the contents of other concepts. So sometimes it's useful to break down system to components. Right, so I'm just drawing these boxes as an idea of clear separation between parts of the system. And then within each component we have basically a set of classes that know about each other existence, and somehow they're capable of interacting with each other. So of course, if you're designing this class, you need to be aware of the ideas already possibly implemented in another class, and therefore you can be more productive building this one. So we need to view each concept in context of the component of the system where it's going to be living, being created, being destroyed, being used, and so forth. Sometimes we just want to view these classes as related classes, so there will be some formal connections between them. And each component in the system becomes the unit of design, documentation, ownership, and reuse. So this is just a proper way of viewing components that we design. So typical design steps are as follows. We start working with functional specification and begin to discover concepts and classes and observe some fundamental relationships. For example, in the course of working with back a few sections, we were looking at the airline reservation system, and we discovered, for instance, this object diagram example, which we can use as a sample in our presentation right here. Okay, so there was discussion about airline reservation system, and there were a combination of objects, so we put together this object diagram. So then, as we identify these concepts, we want to refine the classes specifying the set of operations. So basically, each component here, like flight, schedule of flights, ticket sale instance, customer definition, all of this could be viewed from two aspects, the set of data attributes and the set of operations. So we normally refine the set of operations, also known as class behavior, and we want to classify these operations. So we need to, essentially, when you think about an operation, we kind of like immediately think what class supposed to be providing this operation. So it's natural to just view a set of operations and discover set of operations and properly give these operations to certain concepts, right? So operations belong to certain classes like this. We also don't want to overexpand early on. We want some level of minimalism. Essentially, it's sort of like state of an art to be able to design this system with minimal set of operations, with minimal set of data attributes, and not overextend to some non-essential levels. We also need to be identifying dependencies. So dependencies basically are when change in one class makes an immediate change in the other class. So we want to probably minimize dependencies, and this can be done through parameterization, inheritance, and specific use of these dependencies. So we will talk about this when we talk about software design patterns in the future. We also want to be pretty clear about the interfaces. So inside the class, when we define a class named customer, what we can have here inside this class, we can have a set of data attributes. right? So data attributes typically in class diagram occupying the middle section of the class in the diagram. And these data attributes that we give to our customer here as an example normally are made private, which means that they're not visible to the outside parts of the system, outside of this class definition. At the same time, the operations that are available with this class typically can also be subdivided into the two categories: those that are public operations, which are visible and accessible from other parts of the system, and those that are internal, which means that they're only used internally by other operations like this and not visible to the outside, right? So this is a typical design of a software class. And so this publicly available set of operations in our definition of our class, those parts that are accessible from other components of the system, this makes a public interface of this class. All right, so we need to be able to have some clarity what operations should be public and what operations should be private or protected operations. Protected is just a variation of a public. And of course, we also want to maintain the clarity about the types of operations that we have that involves what sets of parameters we need, and also what kind of information our operation may return as functions back to the rest of the system. And here we again talking about the public operations. So of course, when we work on individual classes, that's the highly iterative process, because we may be able to do a little bit of work on the ticket sale and then decide to add new operations to the customer class right here, because now we need them, because the ticket sale will want to access them, and so we need to make this type of progress. So all of this activity is pretty iterative in nature. Locating these classes and identifying them. So to find the concepts in classes and most fundamental relationships between them is a key to good design. So what is the practical methodology? What is the approach to deciding what classes we need and what their responsibilities should be and how they should be defined internally in our software as concepts? So that's a big question that we have to answer.